are fresh and you are ready for another non-technical talk, and we had a debate with the organizer of this conference because I was asked to do more technical talk, and I was reflecting a lot on that, and then I realized that in my opinion, currently in data science field, we are in another stage where we have to focus more on how we are doing things, not what we are doing. And I think that a lot of technical problems that we had, we already gone through. So my name is Karolina. I am basically doing data science for all my career. It happened so that I started doing data science when it hit the industry. So I was very fast on hitting into all the problems that comes with data science, meaning that main production platform for data science or machine learning products is what? PowerPoint. And projects are dying along the way, and it's very hard to deliver on ML. So I started reflecting on what is happening in this area and why it's not that easy to deliver on machine learning while expectations were really high. And I am talking now about 2014, 15, 16, and it became an interest of mine to dig into why it is so hard to deliver and what to do with this. And since then, I became a manager of data scientists, nice people doing the real job here, and I had an opportunity to test some ideas, and I talk a lot about deployment. I talk a lot about our bias towards data and how to dig with that, but this talk is not going to be around that. And during my career, I built a lot of models, and I built a lot of useful models. I built a lot of models that no one cared about, and then I wrote a song about my job. And if you have heard anything similar, there's just a consequence, yeah? So basically what I'm going to tell today that the most problems I faced as a manager of data scientists and as a data scientist myself were not related to statistics. They were not related to algorithms, and they were not related to Python syntax. Python syntax use Stack Overflow. It's been here for ages. Algorithms, machine learning algorithms, been here in our world since 1960s probably, yeah? So they are here for the long time. Statistics, even longer. And still, when we try to combine everything and build data-driven product or machine learning model, somehow we are facing some challenges. So setting the scene, we are about to build the model. And we are, as right now today, full of energy, full of enthusiasm, and we are ready to kick off. And then we are thinking about using cutting-edge algorithms, new algorithms that just emerge into the market, and we are thinking that we are going to think hard and do a lot of work and apply, I don't know, 10, 20 algorithms and find the best one, and then we are going to stand next to the Wall of Fame, and we are going to have a model, right? But in my career, reality looks like this. Not all the time, sometimes. Who can relate to that? Okay, so you are true heroes. Okay, another question. How many of you are working as data scientists? Okay. Then I will be listening to you next time. So what I face that, data scientists are coming with a very good reputation, with this, red cape of reputation that, they're very smart people, thinking hard, working hard, and development phase, what is happening there? Too much time on data, too little time for algorithms. You can relate to that, no? So I've been recently asking one data scientist, probably it's the 10th model that you are building now. And each time you are telling that you are spending too little time on algorithms and too much time on data. Is it about the time to change that, or a bit reflect on that? That's always the case. And the deployment phase. And Philippe, in the afternoon, is going to talk about machine learning deployment issues and how to deal with those. And I know Philippe for a very long time, since I've been a student, and I know that he's working hard on that. So he will tell more about the deployment, and I'm going to talk about how to work and how to deliver on machine learning models. So. Since I became manager, later head of data, I started talking a lot with higher management of companies or so-called stakeholders. And what I noticed, most of them, they see machine learning as a magic. So you have data, you put the data into, a box, a black box, yeah? And then you do some magic with your fingers, and then, ta-dam, there is a result, and they expect to sell the result and get a lot of money, and everyone is happy, right? How do we see what is data science, and how do we see the development of machine learning model? So a lot of work with data. Again, too much time on data. I'm ironic here. It's never enough time working on data. Machine learning model, it's not only picking the algorithm, it's also tuning, feature engineering, exploring, validating, yeah? And the result, it's not only the cake and celebration, it's documenting, ouch, yeah? Deploying, fixing, calibrating, monitoring, and retraining again. So it's never-ending story, right? And on top of that, we have bias, ethnicity, security, IT security, all type of compliance. So it's really overwhelming for data scientists to deal with that. And I'd like to ask you, what is machine learning model? Anyone? Okay, we can pick awkward silence. So what is machine learning model? Yeah. Okay, finding a function that generalizes all the data. Okay, we have answer number one. I have now there is the second round. I have some answers for you. Yeah. So is it the algorithm or the piece of code? Do we want to vote, or do we disagree or agree with both? Tell me your feelings. We are having a therapy session here. So machine learning algorithm, machine learning model, algorithm or piece of code? Yes, Aurimas. I know. Yeah. Okay, so computer science is both piece of code and algorithm, right? Cool. Okay, another one. Okay, so it's wider than these two, right? Okay, we're going to another level. Or is it a model flow? Agree, disagree? Because we got to the stage where that it's, machine learning model, it's more than that, right? It's more than piece of code, it's more than algorithm. Or, and I know I'm getting extremely annoying here, so I will stop soon, is what end users see. So how do you feel right now? Poker faces, okay. So my point here, and who actually noticed that my talk is data-driven products from zero to hero, and I'm talking about machine learning models. If you notice that, then cool, I'm doing this on purpose. Because I think that's the problem. Because when we are talking a bit about machine learning, we are talking about some parts of data-driven product. Because in my opinion, it is idea, communication around that idea, definition of the problem, requirements, then planning, decision framework, forming, development, again, working with data, deployment, and the result. In my opinion, it's all of that. And getting back to this magic thing, I think that machine learning model is like, this rabbit that comes out of the hat, and we all have different perspectives, yeah? So machine learning model, a rabbit, a data-driven product, it's here, yeah? And data scientists are looking into this product through the computers, through the screens of computers, through the algorithms, yeah? And they see one perspective, product owner, stakeholder. They are keen to present this rabbit on the stage and share with everyone, and data ops behind the curves, DevOps, data engineers, they are just wishing not to stay awake all night and fix, the model flow, that something is not running into production. And there is the audience, the users. And why I love this illustration, I hope I'm not the only one, because this explains that we are looking into this product machine learning model or data-driven product from the different angles, meaning different perspectives. And that's why we have to be specific, and we have to come up with the common language of how we are developing machine learning models, how we are developing data-driven products, because it's not the same for everyone who is working with that. And when I showed the slide that management, they see this, as a magical magic that you throw the data into the algorithm and then get a result. I'm working with them to change this opinion and change this approach, because this shouldn't be. We are working on the same product altogether, and all the elements are necessary. So have I convinced you that data-driven product is not only machine learning model, it's much more? Yes, no? Okay, cool. Thanks, you are very nice. So if we agree that it's a data-driven product, that it's much more, then we can agree on the product development path, right? So I took here the very standard product development path. It starts with the idea, then project managers, product owners are running around the organization, gathering requirements and documenting all the requirements. Then they are doing the roadmap, planning everything. And then on top of that, they are drawing the design, and they are coming to you, dear data scientist, and then they are presenting you a very nice gift. All documented requirements, what to do, when to do, how to do, right? And then you as data scientists are building this, and then someone should validate this, right? And if it's working fine, then you are deploying it. If it's not working fine, you are fixing it, and after you fix it, you deploy it. Is it okay? Bureaucracy, yeah. We don't like visa. What's wrong with that? Yep. Yeah, thanks, Sharunas. You have to reiterate the progress because data science is not software engineering. We have to work in iterations, right? So what can go wrong? So first and foremost, not all ideas supposed to go into production. That's the most important thing that I learned during all my career. Why? Because we are working with data and we don't know what we will find in this data, yeah? We might have an idea, and hopefully we have a problem, yeah? And if we don't have the problem, we should come up with the problem. But another good example about the roadmap. Once I've been asked to prepare a roadmap, AI roadmap for organization. Organization had no data, an organization had no defined problems. And then I told, you know, guys, I studied astrophysics. I can come up with a horoscope, AI horoscope. How does it sound for you? And their answer was, great, yeah, let's do this. So the roadmap in this stage, where you don't know what is going to happen, is silly. And actually, I had one team, and actually this team is here today, where we worked together, and I told, you know, guys, in this team we have no deadlines. Because data science for me is like no deadlines. We can say that, you know, next week I will try to do this or that, but no deadlines. And so far, that's the most productive team I've ever seen. Okay, what can go wrong? About the validation. Validation comes too late, and actually Sharunas pointed it very well, that it's too late to check. And, you know, psychologically, if you're working on something half a year, and someone is coming to you and saying, you know, sorry, it's not going to work, you have to leave it. And I guess that a lot of data scientists experience that. So if you have to leave it after half a year, what are you going to write in your end-year review or whatever those processes mean, yeah? Of course, it's silly. It shouldn't bother you at all. But then it's better to understand that the idea is not going to work ASAP. Okay, what to do with this? I'm recommending you 2 books. These are not about data science. These are about basically doing the work. So one is Inspired, and another one is Continuous Discovery Habits. So idea is very simple. I won't go into details. You have a backlog of ideas and problems that you want to solve. A backlog, usually, especially managers are afraid of having backlogs of, you know, projects, because then there's a feeling that you have to rush into something, right? But actually, backlog of ideas allows you to pick what is the most important thing, yeah? And it allows you to experiment and find that, okay, this idea is not going to work into production. And then you can pick just another idea and work on another idea or and prototype, and I will go into this a bit later on. So also, a very important thing is to have dedicated time and dedicated team, or, you know, have persons who are ready to experiment and build prototypes. And those people should have courage to say that, you know, this is not going further. We should stop here. Another recommendation is, I call this my Bible, and who knows me knows that I'm walking around with this book all the time. So it's basically how to build and test products in 5 days. And it's what I learned during, what I learned using this book. So first of all, that we, as data scientists, we jump into solution mode right away when we understand the concept of the problem. And we skip the part of understanding the problem. So, you know, as Einstein said that if you would give me a problem, I would spend, and I would have 1 hour to solve it, I would spend 55 minutes on thinking about the problem and 5 minutes on solving that. I am applying this straightforward to data science. We have to really understand what is the problem and what are we going to do with the problem. Then another good thing is visualization, because a model in general is a very abstract concept. And one exercise I like to do is to invite people to the same room and say, okay guys, we are building a model. Can we draw? Can we take 15 minutes and draw the model? How do you imagine how the model should look like? And then everyone is just like, how to draw the model? And there are some good techniques in this book. So basically, when people are drawing the model, or whatever parts of the model that they want to build, we see very different outcomes. So how can we work together if we have very different visualizations in our mind? So do this at the very beginning of each project. And then a prototype. Basically, according to this book, there is only 1 day to build a prototype of the model if we are working in data science, data-driven product, if we are talking in data science context. And basically, then we are forced into regime important, not important. And those things that we are saying not important on that one day, I realized that during scale up and when we are going to, the full project, those things are usually, the deal breakers. That usually we are spending a lot of time and then they are not working. So I came up with this idea that as human beings, we have a very good sense of what is going to work, and we are just sometimes we want to do everything. That's why we are, drawing into into tasks and forget the main idea that we are building a product here. Quick one. While I was doing this presentation, I realized that there is sometimes a bit of buzz around what is the proof of concept versus prototype versus minimum viable product. So proof of concept, you can draw on the paper basically just to say, is this idea doable, yeah? Prototype, you put a bit of visualization in order for your stakeholders and users to see it. But the back end is, it can be zero basically, or it can work on one client, for example. Minimum viable product is providing basic functionality and launching it into production. And when I hear that, our team is very agile, we are starting with MVPs. And then I say, hey guys, you have, one big problem. There is a product, word product, and everyone is expecting you to deliver a product. So another quick recommendation, agile and data science relationship being complicated. So I really recommend this book. There's a QR code to Git repo of them. And to wrap up, methods and everything that you are doing, and I can promise you that if 1 year later I will stand up on this stage, I will give you another recommendations. I can name you different new books, but never forget one thing, that it is always about solving the problems, and it should always start with the problem. One problem might have different solutions. Give yourself time to explore those solutions. If you are building machine learning model, it can be a dashboard. If you are getting back to your stakeholders after 1 month and saying, hey, we agreed on machine learning model, neural nets, that was cool, but it's enough to do a dashboard, then you are a hero. And then let yourself prototype and experiment and have fun with data science. And data science is about solving problems, not doing magic. Thanks.
Thank you.